ladies and gentlemen, we're going to take a look at the properties of tangents. So we're going to take a look at those. We're going to introduce a new word, tangent segment. So it's simply a segment. So this is something that we can measure. So we can give length to it. That has one endpoint on the circle. So it matches up with what we know of tangent line, where it intersects the circle one time. This only has one endpoint. So let's take a look at theorem 11.1. If a line is tangent to a circle, then it is perpendicular to the radius. At the point of tangency. All right, so this point of tangency is where we're now going to be perpendicular to that radius. So we have a 90-degree angle there. So what that looks like is that CB is perpendicular to line L. Okay? Theorem 11.2 kind of goes in the reverse order. If we know a line is perpendicular, so now we just know we have a line. We don't know anything more about it. But if we know that line is perpendicular to the radius of a circle at its endpoint, then the line is tangent to the circle. So in symbols, once again, if CB is perpendicular to L, then L is tangent to the circle. So what's the relationship between these two theorems? Well, they're what we call the converse of each other. They're converse theorems, and that goes all the way back to first semester. All right, we start with a conclusion, a hypothesis, and go to a conclusion. The next theorem, we go from conclusion to hypothesis. Sorry, guys. So let's take a look at example 1. We want to use the properties of tangents. So we know BC is a tangent, or is a radius, I'm sorry, of circle B. So we can imply that BC and AC are perpendicular because they tell us already that AC is tangent. So that means angle BCA is a 90-degree angle. And that means it's a right triangle. So to use that, to find what our lengths are, we're going to use Pythagorean theorem. We're trying to figure out what is the length of that radius. So if we think about what Pythagorean theorem is, it's the hypotenuse squared is equal to a leg squared plus a leg squared. So our hypotenuse is 13. BC, we don't know. We're still trying to find that. But CA is 12, so we square that. This is 169 is equal to BC squared plus 144. We're going to subtract that 144 from each side, and that gives me 25. And then your last step, as it has always been, is to take the positive square root. So BC is 5. So now we know the length of the radius. So that's one of the ways that we can use these tangents, is if we have different measurements, we can actually use that to find our radius, which is pretty valuable. All right, now we're going to find the radius again, but we don't have quite as much information. I know I'm staying at point C, and the distance there is 8 feet from the silo. I also know that the point of tangency is 16 feet from that same point C. So what we want to know is what is the length of the radius. So we've got this radius here that we're going to try and find. All right. So how do we do that? Well, we know that tangent BC is perpendicular to the radius. So triangle ABC is a right triangle. So we can use the Pythagorean theorem. All right, so as always, the hypotenuse squared is equal to leg squared plus leg squared. So we want to fill in what we know. Well, let's take a look at what that hypotenuse is not 8, guys. 8 is just the outside measurement of it. And we should know that it's not that a hypotenuse can't be 8 because one of our legs, BC, is 16. I know my hypotenuse has to be larger than that. So how long is my actual hypotenuse? Well, it's whatever this radius is going to be that I'm trying to find plus 8. So that whole quantity has to be squared. My other leg is the radius, so this is r squared. So now it says to multiply. Well, if I look at this right-hand side, r squared is pretty easy to do, and 16 squared is pretty easy because I can do that on my calculator. It's 256. But what I have to figure out is how do I take r plus 8 and square that? Well, let's think back to Algebra 1. R plus 8 squared means r plus 8 times r plus 8. That's what it means to square something, is to multiply it by itself. And so what I'm going to do is do r times r, which is r squared. Some good algebra review here. R times 8, which is 8r. 8 times r, which is 8r. And then 8 times 8 is 64. You're going to combine your like terms, and in this case, we only have them there in the middle. So our first term is going to be r squared. We have plus 16r. And we have plus 64. We're going to subtract r squared from each side. You're not going to have quadratics here, guys. We're going to subtract r squared from each side. So we're going to minus r squared minus r squared. And that leaves me with 16r plus 64 is equal to 256. You then have to subtract 64 from each side. And so when we subtract the 64, we're going to be left with 16r. I need to take 256 minus 64, and that leaves me with 192. And then we're going to divide each side by 16. And so when we divide by 16, we get 12. So the length of our radius, or the radius of the silo, however we prefer to say that, is 12. I need to go look and see if I have any units. And I notice 16 feet up here, so that means this is 12 feet. My hypotenuse is not 12 feet, guys. My hypotenuse is 12 plus 8, which is 20. So the hypotenuse is still the longest side of that triangle. It's just this inside radius here is going to be 12. All right, let's keep going and take a look. Now I want to verify that I have a tangent. To do that, you're just going to work back through the converse of the Pythagorean theorem. So we want to prove that we actually have a right triangle. So you're going to do hypotenuse squared is equal to leg squared plus leg squared. So we're going to substitute the lengths we have. We have to make sure it's always the longest side by itself. And then 9 squared plus 12 squared. 15 squared is 225. 9 squared is 81. And 12 squared is 144. When we add those together, this side is still 225, but when we combine those terms, we also get 225, and so they are equal. And so because we end up with equal segments there, equal measurements, we know that we have a right triangle. And so because this right angle is here at E, and we're trying to, that E would be considered a point of tangency, we know that EF is tangent. Oops, I'm sorry, that's not the word they're looking for us to fill in there. I'm getting ahead of myself. Is perpendicular to DE. So, by theorem 11.2, it follows that EF is tangent to the circle D. All right, now we've got our last couple of examples. I think it's our last example, actually, and we're going to look at what some of the properties of tangents are. We know they're going to intersect the circle at a 90-degree angle, but these tangent segments, now that we can measure them, actually have a better property than that. And so, what we know for these properties of tangents is theorem 11.3. If two segments come from the same point outside of the circle and are tangent to the circle, then they are congruent. So we do need to fill in theorem 11.3 first. And so what does that mean in symbols? What that means, if SR and ST are two tangents, then we know SR is congruent to ST. We know they have the same angle measure. So now let's take a look at how that helps us solve example 4. We know AB is tangent to circle C, and AD is tangent to circle C. So that means those two are going to be congruent. We know that AD is going to equal AB. So 2x plus 3 is going to equal 11. All right, we're substituting that 2x plus 3 in for AD and 11 in for AB. You're going to subtract 3 from each side and get 2x is equal to 8. And then divide each side by 2. We get x is equal to 4. The next follow-up, what I want you to do is to prove that 4 is the correct answer. So actually, let's substitute that 4 in for x. So 2x plus 3 was our length of AD. That means 2 times 4 plus 3. That's 8 plus 3, which gives us 11. So why should AD equal 11? Because AB equals 11. They should be the equal measures. All right, we've got 2 checkpoints. Let's do those together, and you guys can get started on tonight's assignment. We need to find the value of x. Well, x is the length of CD. Well, we know CD is equal to CB because they're both tangent to the same circle. So we know x is equal to 15. Doesn't get a whole lot easier than that substitution there. If we take a look at the next one, we know CB is congruent to CD. So we know 3x plus 5 is equal to 14. Minus 5 from each side, and you get 3x is equal to 9. Divide by 3, and we get x is equal to 3. All right, ladies and gentlemen, that's all I have for you today. Have a great day.